Picture an engineer laying out the center line for a bridge deck. She marks the midpoint of each side, then checks that the crossbeam lands exactly halfway and parallel to the base. Today you will learn the midpoint theorem and walk through a clean step-by-step proof that shows why this shortcut always works. Start with a triangle ABC and let E be the midpoint of side AB, so AD equals DB. Let E be the midpoint of side AC, so A equals EC. The midpoint theorem claims the segment D is parallel to BC and its length is exactly half of BC. To prove this, draw triangle ABC. Mark D and E. Then construct a line through D parallel to AC meeting BC at F. Now focus on triangles AD and DFB. Angle AD equals angle DFB because they are corresponding angles formed by the parallel lines. AD equals DB by the midpoint definition. And angle DA equals angle DFB. So by angle side angle the two triangles are congruent. That congruence forces D to equal FB and A to equal DF. Since E is the midpoint, A equals EC, so DF equals EC, making DFC a parallelogram. In a parallelogram opposite sides are equal, so D equals FC. And since DF equals EC, the whole segment D is half of BC. Because DFCE is a parallelogram, D is parallel to BC, proving both parts of the theorem. Let us plug in coordinates to see it numerically. Take A at 0, 0, B at 4, 0, and C at 0, 6. Midpoint D of AB is 2, 0, midpoint E of AC is 0, 3. Vector BC is 4 units right then 6 units down, while vector D is 2 units right then 3 units down. Exactly half the components. The direction numbers stay proportional. So D is parallel to BC. And the length of D is root 13 while BC is root 52. Confirming the 1/2 ratio. Engineers use this fact when they place a mid-span support beam. By connecting midpoints they know the brace will run parallel and be half the main span, saving material and time. So the midpoint theorem tells us that joining the midpoints of two sides of a triangle gives a segment parallel to the third side and half as long. Remember the key idea. Construct that parallel line. Prove congruence. And the properties of a parallelogram finish the argument, giving you a reliable tool for geometry and design.